Hello, my name is Ollie Adams, and the name of my game is Silica. Silica is a fantasy adventure game where the player explores an environment, interacts with characters, completes quests, and collects items to progress through the world. The main objective of the tutorial section is to retrieve a potion for an old man. To complete this objective, the player must explore the area, interact with NPCs, collect the required item, and return it to complete the quest. The core gameplay loop of Silica is based around exploration, interaction, and progression. The player explores the environment, communicates with NPCs to understand objectives, completes quests, and receives rewards that allow them to progress. I designed this structure to encourage the player to engage with the world and understand the purpose behind each objective, rather than simply completing tasks without context. Throughout development, I focused on creating a modular structure where different gameplay features are separated into individual systems. This allowed me to organize the code more effectively and make the project easier to maintain and expand. For the implementation of Silica, I divided the game into several systems rather than placing all functionality in a small number of scripts. Each system has a specific responsibility, which makes the code easier to maintain, debug, and extend. The main systems I implemented were audio, dialogue, quests, inventory, and saving. The audio system is split into two scripts, the sound effect manager and the sound effect library. The sound effect library is responsible for storing and retrieving audio clips, while the sound effect manager controls when sounds are played and manages settings such as volume and pitch. I separated these responsibilities using the single responsibility principle, meaning each class has one clear purpose. This prevents one script from becoming too large and allows individual parts of the system to be changed without affecting the other systems. The sound effect library uses a dictionary to organize sounds by name. Each sound can contain multiple audio clips, allowing the system to randomly select variations of the same sound effect. This helps reduce repetition and makes the game's audio feel more natural. The sound effect manager also uses a singleton design pattern. A singleton ensures that only one instance of a manager exists at a time, allowing other scripts to access the audio system without creating multiple copies. The dialogue system is made up of the dialogue controller and NPC script. The dialogue controller manages the visual side of dialogue, including displaying the NPC name, portrait, dialogue text, and creating dialogue choice buttons. The NPC script controls the conversation logic and decides which dialogue should be displayed depending on the player's quest progress. NPCs implement the iInteractable interface, which allows a contract requiring objects to contain specific interaction methods. This allows different objects, such as NPCs and other interactable objects, to use the same interaction system without the interaction code needing to know what type of object it is communicating with. I also use coroutines to create the typewriter dialogue effect. This allows the text to appear gradually over time without stopping the rest of the game. Dialogue choices are created dynamically using prefabs, meaning NPCs can have a different number of options without requiring separate UI layouts. The quest system is divided into four components: the quest class, the quest controller class, the quest UI class, and the quest database class. The quest class uses Unity scriptable objects to store quest information separately from the gameplay logic. This allows new quests to be created inside of Unity without changing the code. The quest controller manages active quests, tracking objectives, checking completion, and communicating with other systems such as the inventory. I used events so that the quest system updates when the inventory changes instead of constantly checking for updates. This makes the system more efficient because updates only happen when required. The current system was designed to be expandable by using different objective types. The current system currently only supports collecting items though. The quest UI is responsible for displaying active quests and objectives to the player. Quest entries are created dynamically using prefabs, allowing the interface to support different numbers of quests. Finally, the quest database stores available quests and retrieves them using unique IDs. This also supports the save system because quests can be restored using their stored identifiers. The inventory system is another central part of Silica because it connects with multiple other systems including the quests and saving. The system is separated into multiple classes, with each class having a specific responsibility. The item class controls individual item behavior, such as storing the item ID, name, and quantity. It also handles changing item stacks and when items are added or removed. The inventory controller manages the overall inventory, including adding items, removing items, tracking quantities, and communicating changes to other systems. To organize items effectively, I created an item dictionary that stores items prefabs using unique IDs. This allows the game to identify and recreate items when loading a save file instead of storing complete game objects. The inventory supports item stacking by checking whether the item already exists before creating a new inventory slot. If the item exists, the quantity increases. Otherwise, the item is placed into an available slot. I also implemented drag and drop functionality using Unity's event interfaces. This allows the player to move, combine, split, and drop items, creating a more interactive inventory experience. The inventory communicates with the quest system through an event that is triggered when the inventory changes. This means quests can update their progress when the items are collected without The inventory system is another central part of Silica because it connects with multiple other systems, including the quests and the saving. One of the more complex functions in my inventory system is the add item function, which controls how items are added to the player's inventory while supporting item stacking. The function begins by retrieving the item's component from the object that has been picked up. I then check whether that component exists, and if it doesn't, the function immediately returns false. This prevents invalid objects from being added to the inventory. Next, the function uses a for each loop to iterate through every inventory slot. For each occupied slot, it retrieves the stored item and compares its unique ID with the ID of the item being collected. If the IDs match, the player already owns that item, so instead of creating another game object, the function calls add to stack. This increases the quantity stored in the item, updates the quantity displayed to the player, rebuilds the inventory item count, and immediately returns true because the item has been successfully added. If the loop finishes without finding a matching item, a second for each loop searches for the first empty inventory slot. Once an empty slot is found, the function instantiates that item into that slot, centers it with the UI using rect transform, stores a reference to the item in the slot, rebuilds the inventory count, and returns true. Finally, if every slot is occupied and no space is available, the function outputs an inventory is full message and returns false. Returning a Boolean value allows other systems to know whether adding the item was successful. I chose this approach because it ensures existing item stacks are always filled before creating a new inventory object, which makes better use of the available inventory space and reduces the number of game objects that need to be managed. Overall, the main focus when developing Silica was creating systems that could communicate with each other while keeping their own responsibilities separate. For example, the dialogue system can interact with the quest system to change conversations depending on player progress, while the save system can store information from multiple gameplay systems. This structure made the project easier to debug and allow new features to be added without heavily changing existing ones. Silica connects to this year's theme of being human through its focus on interaction, helping others, and creating connections between the player and characters within the world. The main objective of retrieving a potion for the old man reflects the human experience of empathy and cooperation, where the player is not simply completing a task, but helping another character within the game world. The dialogue and quest system support this theme by allowing NPCs to communicate with the player and provide context behind their objectives. Instead of quests only being represented as simple goals, the player learns why they are helping their character, creating a stronger connection between gameplay and storytelling. One aspect that went well during development was creating separate systems that could work together. By dividing the project into systems such as dialogue, quest, inventory, audio, and saving, I was able to develop features independently while still allowing them to communicate with each other. Another successful part of development was creating reusable systems. For example, quest systems can support different objectives, and the dialogue system can support multiple NPCs without requiring separate code for each one. One area that did not go as smoothly was debugging communication between different systems. As the project became larger, changes in one system could sometimes affect another, meaning additional testing and troubleshooting was required. If I continued developing Silica, I would expand the game by adding more quests, NPCs, interactions, and more complex dialogue choices with consequences. I would also improve the save system by adding features such as multiple save slots and a stronger error handling. Overall, this project has helped me develop my understanding of how programming systems can be combined to create an experience that is not only functional, but also meaningful for the player. During the development of Silica, I used several YouTube tutorials to help me learn and implement new programming concepts. For example, I used Gamecode Library's tutorial called Build Any 2D Top-Down Game in Unity, which helped me learn and code the majority of my game. I also referred to Bendux's How to Make 2D Portals in Unity tutorial, which was used when the player enters a cave at the northern side of the map. Rather than copying the code directly, I adapted it to fit the needs of my own game by changing the object teleporting to the root object, as the portals were teleporting my interaction detector as well as the character, which resulted in the detector teleporting twice as far. Using these tutorials allowed me to improve my understanding of Unity and C# while still meeting the project design goals. They acted as learning resources, helping me understand the techniques behind the systems before integrating them into my own application.